Vector's free response question. Alright, so the situation is a cannonball with an initial height of 1 meter above the ground is fired from a cannon at an angle of 50 degrees above the horizontal. The cannonball travels a horizontal distance of 60 meters to a 10-meter high castle wall and passes over 2 meters above the highest point of the wall. Assume air friction is negligible. How much time does it take for the ball to reach the wall is question A. B. What is the initial speed of the cannonball as it is fired? C. What is the velocity of the cannonball as it passes over the wall? Alright, so for A, how much time does it take for the ball to reach the wall? So for the vertical component of the cannonball, it's initially 1 meter above the ground, and it ends 12 meters above the ground because the castle wall is 10 meters and it goes 2 meters over. And the acceleration is negative 9.8 meters per second squared because of gravity's constant on Earth. Time is the variable we're looking for. Alright. And also, velocity initial is the velocity times the sine of 50, because that's the angle of trajectory. Alright, so the change in the y component is equal to velocity initial times time plus 1/2 acceleration t time squared. 11, because the change in the y is 11, 12 minus 1 is 11. 11 equals velocity sine 50 times time minus 4.9 times squared. And now to go to the horizontal part. The x is equal to 60 meters because that's how far away the wall is. And the velocity is in the x direction is velocity cosine 50 because cosine is the x component. Time is a variable. Velocity of the ball is change x over time, change in position over time, and so the velocity v cosine 50 is equal to 60 over time, or you could rearrange that to mean the velocity is equal to 60 over cosine of 50 times time. And then once you have, because for the vertical component, you have 11 equals that velocity times sine 50 t minus 4.9 times squared, and you have v velocity as a variable and also time as a variable. You can plug in what you got for velocity in the horizontal component and substitute it for the part in the vertical, and then you would get 11 equals 60 over cosine of 50 times time, all in parentheses, times sine 50 minus 4.9 times squared. And once you do the calculations, that's 11 minus 60 tangent of 50 equals negative 4.9 times squared, and time is equal to the square root of 12.3, which is equal to 3.51 seconds. So it takes 3.51 seconds to reach the wall. What is the initial speed of the cannonball as it is fired? So now that we know how much time elapsed, we can substitute back in one of the initial equations to determine the initial speed. And the velocity is 60 over cosine of 50 times time, which is equal to 60 over 3.51, because we know time is 3.51 times cosine of 50. And solving that, you get 26.6 meters per second. Now That is the initial speed of the cannonball when it's fired. C, what is the velocity of the cannonball as it passes over the wall? So, for C, its velocity will be the combination of horizontal and vertical velocities. Therefore, we can reason that velocity in the x is equal to x over time, position over time, which is equal to 60 over 3.51, because that's the change in x, which is 60 over 3.51, which is the time, which is equal to 7.1 meters per second. And then velocity in the y direction final is equal to velocity in the y direction initial plus the acceleration times time, which is equal to, once you plug in the variables, then you get negative 14 meters per second. And then the velocity, because you can use the Pythagorean theorem, velocity is equal to the square root of 17.1 squared plus 14 squared, which is equal to 22.1 meters per second. And that is the velocity of the cannonball as it passes over the wall.